Alright, I have finally finished Advent of Code Day 18. I was recording live, but this one ended up taking a lot longer than I wanted it to. So in this problem, we're given numbers within brackets. They're called pairs, and each element of the pair can either be a number or another pair, where at its base level, it's number and a number. So we have to reduce all of the pairs. So to do that, there's two operations you can do. One of them is called exploding the pair. So if it's nested inside 4 pairs, then you explode it, which means, as defined down here, you basically make the number on the right get added to the number that's to the right of it. The number on the left gets added to the number that's on the left of it. So down here, this 3 gets added to the 4 for 7, and 2 can't add anything, so it just becomes a 0. And one tricky thing with this is it says if it's inside 4 pairs, so what that really means is you have to be inside of 5 brackets of depth, or the number has to be, rather, because the pair itself is within 4. And then, besides exploding, you can also split. So you split whenever there's a number that is 10 or greater. Then to split it, that means you divide it by 2 and you round down and you're making a new pair. So after you've divided by 2 and rounded down, that's the number on the left. And with that initial number, when you round it down, or you divide by 2 and round up, and that gives you the number on the right. So as shown down here, 13 becomes 6 and 7 as a new pair instead of just a single number. So in part 1, what we had to do was figure out the magnitude. So what that means is the magnitude. So you're given a lot of pairs on separate lines, and so to combine pairs, you basically take the first one, put a comma at the end, and then append the second one, and then just put brackets around the whole thing. So that gives you one pair, and to get the magnitude of a single pair, that is equal to 3 times the number on its left side, and then add that to 2 times the number on the right. So you can recursively get the value of a pair. If it's made up of pairs, then its value on the right is just the magnitude of the pair on its right. So yes, for part 1, you need to find the magnitude of the final sum, where your whole input is like 100 lines of this stuff. And so you have to, you go down in order. So first you find the sum of these 2 lines, and then the result from that, you take that and add it to this one. One thing to watch out for is that addition is not commutative, like in normal math, because it's equal to 3 times the value on the left and added to 2 times the value on its right. So it's not commutative, of course. The way I went about this, we have a function for split. It's pretty straightforward. You basically redefine the area that was taken up by the number greater than or equal to 10 with its rounded down and rounded up version after you divided it by 2. And then we also have explode. One thing to watch out for is I assume this came up at some point. I didn't check, but I assume this would have come up in the 100 lines of input. It could be the case that you end up when you explode, then you're adding on to a number that was already greater than 10. You have to kind of watch out for that. So that's why I did this kind of weird check here. You basically keep moving left as long as you see a number, or rather, once you see a number, keep moving left until you don't see a number, so you know the bounds of the number that you're about to add to. And then same on the right side. So once you've found that, and then you can add those, add the left and right side of your current pair that you're exploding, the numbers that you found. One other thing to watch out for here is whenever it's like order of operations. If you go inside parentheses in order of operations, you basically restart, like go back, all right, look for parentheses, exponents, and so on. It's the same thing here. Once you split something, for example, you go back to the top and try to explode something. Once you explode something, look for more stuff to explode, essentially. So that was one tricky part. So eventually get that here. So I have a function to look for something to explode, and if you find something, then you need to go back to the top and try exploding more. And we also look for a split. So this one is slightly different because once you find something to split, you don't want to go back to the top and look for more things to split. You want to like get out of here and look for things to explode instead. So that's what I have down here. First, we try to explode stuff, and that keeps that keeps repeating itself until nothing's changed. And then we look for things to split, but we only do that once, and then we try to go back to exploding things. And basically, as long as the string has changed, then you want to keep repeating this process, but once nothing's changed, then nothing's ever going to change at that point, so you break out. So this is just to parse the input, because that weird way you add this line to the second one by putting a comma and then the brackets on the outside of these two. And this was a debug thing just to figure out the depth of something. I just print what the depth of something is, which I guess I deleted those lines. So we just had print depth, and then the end is nothing. And then at the end, we just print. Yeah, again, that was more debug. So to handle getting the magnitude, I made a class for that, and I used exec cheese here. So exec command, what that does, you basically pass it a string, and it'll run it as Python code. So that's what I did here. You'll notice it's complaining like, hey, you didn't define OB. It's just, it can't recognize that I'm using it within the exec command. So I basically wrap, instead of using square brackets, I change those to be parentheses and just wrap the whole thing. So here, if I print this here, it's formatted, and we go back to here, sure, we'll run this. That's not, oh wait, I don't want to show the depth. Oops, depth. Yeah, don't show the depth. Don't need that anymore. Okay, yeah, so here's what it looks like. I'm gonna stop it there. Yeah, it basically parses each line and wraps it as if it's making an instance of an object. And then I'm able to use this logic up here. So if the first thing passed in was a number, so for example right here, it's 3 and 5. So those are both numbers. So we don't have to go down any farther, but let's say we're looking at this pair here. Then the number on, or the value on the left is a number, but then this evaluates to a pair. So if it's not an integer, then we want to get the magnitude of its right or left side, in this case the right side. So you just recursively get the magnitude of each object. And this is just to format the string. Okay, so part 2, it's like, alright, that's great, but you want to now find the largest magnitude you can get to by adding only 2 of the lines together. So instead of adding up the whole thing, you want to add just 2 of the lines. So you can, I don't know if this is cheese, quote unquote, but you just do permutations of size 2 and just try every combination. I don't think you can do caching. I could be wrong about that because anytime you add, like, let's say the first line and like the seventh line, that's like unique answer to anything else, or rather, if you calculate the magnitude of each line, that doesn't help because it only matters what the magnitude is when you combine it with another line, and it's like kind of unrelated to what its initial magnitude was. But again, it could be wrong. Maybe you can cache it somehow. If we stop printing the formatting, using PyPy, my code runs fairly fast. It's like 10 or 15 seconds. So that's part one, and wait for part two. But yeah, that is day 18. We'll see if tonight is another hard problem because it's a weekend night again. We will see. Yeah, you should define the largest number that you could get after trying every combination from the input. Seems to be taking a little bit long, but yeah, maybe there's a faster way to do this. Yeah, there's the answer. Alright, so that is day 18. Thanks for watching.